Welcome to today's presentation entitled Cradle to Grave Filtration and Purification in Nuclear Power Plants and Processing Facilities. My name is John Ferrara, and I'm the Vice President of Global Nuclear Sales at Pall Corporation. Before we get started, just wanted to go over a couple of housekeeping items. First, the presentation today runs about 30 minutes, and you will have the opportunity to ask questions. If you notice the Q&A window on your screen, you can enter and submit these questions during the presentation. And at the conclusion, we will address as many questions as we can, given the time allotted. Thank you. So who is Pall Corporation? For 70 years, Pall Corporation has been a global filtration and separation technology leader. We have deep knowledge of customer applications combined with unmatched engineering capabilities. We are truly a worldwide company with local technical support around the globe, and we continue to deliver the most innovative process solutions. In order to serve the diverse end markets more effectively, Pall Corporation is divided into two major business units, Life Sciences and Industrial. Underneath Life Sciences, you'll see biopharmaceuticals, medical, and food and beverage. Underneath Industrial, you'll see fluid technology and asset protection, aerospace, and microelectronics. Nuclear, which is today's focus, falls under what we call the FTAP group. Some of the more common FTAP applications are shown on this slide. In the upper left is the UltiPleat high-flow filter with laid-over pleats for more efficient particle removal in high-flow rate industrial applications. In the upper right is the Pall Aria water treatment system for removal of contaminants from source water to produce pure water in municipal and industrial water applications. Bottom left is the T-range filter housing, which removes fine particulate contamination in mobile equipment, mining, rail, agriculture, and construction industries. And the bottom right is the phase-sep coalescer, which separates liquid-liquid emulsions in the oil, gas, and chemical industries. The UltiPleat SRT filter is a good example of product innovation and platform enhancement at Pall Corporation. This is a best-in-class hydraulic and lube oil filter with laid-over pleat design. Its improved design achieves the highest level of system protection and enhances equipment reliability and productivity, extends service life, and reduces waste. No one can argue that fluids are critical to operations, especially in nuclear power plants. Nothing impacts the operation, reliability, and productivity of a power generation plant as the quality and purity of flows flowing through it. For example, iron oxides in feedwater. They will degrade steam generator efficiency and force unplanned outages from corrosion tube failures. Moisture and particles in lubricating oil will cause corrosion and scoring of turbine bearings. Microscopic radioactive particles in nuclear primary water increase plant contamination levels and cause coolant pump seal erosion. Moisture and gases in dielectric oil accelerate aging and maintenance costs of power transformers. And finally, bacteria in cooling water will foul heat exchanger tubes and can endanger plant personnel. TFM, or total fluid management in nuclear power plants, is depicted on this slide. We show a PWR, or pressurized water reactor, although a lot of these applications would also apply to BWRs, or boiling water reactors. In typical fashion, nuclear plants are divided between the NSSS side and the BOP, or balance of plant side. So starting on the lower left, the nuclear primary coolant submicronic filters. Those filters are below 1 micron. They could be 0.5 or even 0.1 micron. These filters are very critical. They protect components such as reactor coolant pump seals from contamination, which will cause excessive leakage. Above that, you have the spent fuel pool, and purifying of the spent fuel pool is just as critical. Keeping that water clear and clean and purified is very critical, not only to just the condition of the water, but also for the clarity to be able to see, especially during fuel moves. Above that, on the BOP side, we have the condensate filtration systems. These are high flow systems, and they can be either backwashable or not, depending on the plant in question. The backwashable systems tend to be on the boiling water reactors, or BWRs. Further on into the BOP side is the turbine lube oil conditioner. I just want to talk a little bit about that because on the BOP side, the applications are very similar on a nuke plant as in a fossil plant. But what's important on turbine lube oil and control oil, and even generator seal oil, keeping the oil cool, dry, and clean is paramount. And the filtration is generally absolute rated coreless filtration technology. For water control, free and dissolved water removal using mass transfer under vacuum would be part of that system shown on the slide. Turbine lube oil conditioners is a combination of filtration, coalescence, and vacuum dehydration for optimum turbine lube operation. And then turbine lube oil mist eliminators, which are high efficiency coalescers that capture aerosols and prevent lube oil mist from escaping the tank. And finally, varnish control in turbine lube oil systems is very important. Using absorption over a high efficiency medium to remove varnish precursors from the oil, displacing equilibrium allows varnish removal from metallic parts, all to prolong the longevity and also increase the efficiency and reliability of the turbine generator components. Diagnostics for steam turbine lube oil is also shown there. Below that, purification of power transformer oil, which would be on the exterior of the plant, and that's very important as well. Steam turbine oil filters shown there, which were described earlier in the presentation, and right below that, what we call the startup condensate filters. Now, these filters are exactly that. They are for startup conditions only, and they are high flow systems that generally will not be used after the plant is in operation, but they are very critical in those instances where the plant is coming back after a refueling outage or after a forced outage, and there's a lot of material in the piping that may have became loose and off of different components, and these systems, these startup condenser filters, will clean that out, and then they will be taken out of service during normal plant operation. And then finally at the bottom is the Paul Aria system. This is the integrated membrane system that we talked about before for water supply and rad waste recycling. Continuing with the TFM concept in the PWR plant, we show the NSSS applications in a little more detail. I know that this might be a little difficult to see as far as some of the components, and actually some of the descriptions are maybe a little bit too small, but I'll try to do my best to explain some of the different applications here. These would all fall under the nuclear submicronic filtration. And again, the main component would be the coolant pump seals. And some of the components that interface with the coolant pump would be the seal injection filters, the seal water return filters, the chemical addition filters on the CVCS system, the reactor coolant letdown, and the recycle evaporator filters. These would all be on the order of submicronic, and they all serve a very important purpose to keep the primary water supply very clean, very pure, to protect not only the reactor coolant pump, but the primary coolant that does go through the reactor and then through the fuel channels and makes its way out in the form of steam through the steam generators. Any kind of particulate, any kind of contaminant that is in the primary system will find its way on fuel tubes, on control rods, on steam generator tubes, and they will tend to foul the system, which not only reduces efficiency, but could enhance or exacerbate the failure of some of these systems and result in an unplanned plant shutdown to either plug tubes in the steam generator or actually have to go look at potential fuel failures that would have to be taken care of. And every day that a plant is down is not only lost revenue, but it's a perturbation that the plant would rather not take, and obviously the NRC doesn't like to see these kind of shutdowns because it's a bad indicator on the way plants are operated and maintained. So water quality on the primary side on a PWR is very, very critical, and these filters are built to maintain the water quality at the very, very highest standards. Just to continue on the steam turbine oil systems, the oil quality, cleanliness, and low moisture content is critical for steam turbine lubrication systems, also for seal oil and turbine lift systems, as well as EHC. So the Paul TFM really encompasses monitoring and testing of all oil characteristics. The optimum filtration with Paul Ultipore or Ultiplete SRT technologies results in longer life, resistance to stress, and cleaner oil. Total control with water removal products for turbine lube oil, and a combination of filtration, ion exchange, and dehydration for EHC fluid reclamation. As well as field services, flushing and spot oil analysis are available during operation of the plant. What this means is the turbine performs, the filtration lasts, the fluids last, and the fluid resource is controlled and monitored. Backwash and disposable filtration. Paul Corporation offers vessel evaluation, upgrades, and troubleshooting services, and some of the options are listed here. The Paul HydroGuard pleated elements. These control iron oxides and particles, very high efficiency elements without the use of pre-coat, and generally about 10 times the surface area than conventional depth filters. The Paul HydroGuard cold R depth elements. These are excellent durability, pre-coatability with the cold technology. These have the option with resin pre-coat for demineralization and upgrade from string wound cartridges. And then finally, disposable filtration. This would be the Ultiplete high flow technology that was talked about before for full flow condensate filtration. This is the best combination of flux and efficiency, 10 times less elements than standard filtration systems. Generally a smaller capital investment. It's an ideal resin bed protection, steam generator protection against corrosion failures as well. These can allow rapid startups, 50% faster in some cases, and they're also proven copper and iron control. A little more detail on the water supply systems, specifically the integrated membrane systems. This is a flexible, inexpensive, and efficient source of water. These are based on the combination of microfiltration and reverse osmosis. These save on water procurement, optimize water quality consistently, increases flexibility, and reduces chemical usage. The Paul Aria microfiltration automatic systems. These are influent, flexible, and effluent versatile systems. 0.1 micron filtration, hollow fiber membrane technology. They stop all solids and bacteria while providing ideal water quality to reverse osmosis. They're automatic self-cleaning, multi-year trouble-free operation. They eliminate most chemical pretreatment of water and are pre-engineered modular and expandable systems. For demineralization, reverse osmosis, electrodeionization, and ion exchange resins are available. And for RO protection, the UltiPlete HP, this protects the RO membranes from high-pressure modules on the RO rack. Moving on to the decontamination and decommissioning part of the presentation, or D&D as it's known in the industry. This has become a very large business. It's starting to ramp up dramatically as plants are either shut down prematurely or are reaching conditions in their current shutdown status where they need to be decommissioned. And the D&D process involves essentially taking that plant completely down to grade level and returning the site to its condition before the plant was built. And this is a condition that is, or a requirement is common here as well as overseas in other countries. So nuclear power plants involve a diversity of filtration capabilities. First and foremost is the reactor cavity filtration and purification. Several 100,000 gallons of water have to be maintained in a clear and filtered condition for workers to be able to not only see what they're doing, but to keep radiation levels and contaminant levels to an absolute minimum. A lot of the material that they deal with will be cut up, and they are very high dose, and they are very concerned with, obviously, spread of contamination and also airborne contamination on refuel floors. Also, highly radioactive fluid decontamination is part of that effort, as well as rad waste system augmentation and replacement. The rad waste systems that are in place will many times be used up until a point in the D&D process, and then they will be shut down, they will be dismantled, removed, and a replacement system has to slide in and to be able to take over. And these are all very critical systems for a successful D&D operation. Processing facilities also demand unique capabilities, dewatering of highly radioactive waste, sludge removal, HEPA filtration for containment gases. These are all unique to processing facilities, and they must be addressed with systems that are designed specifically for that application. I want to talk about the reactor cavity filtration system to start. You'll see the UltiPlete system. This was mentioned earlier. This is common in high flow condensate systems. This lends itself very nicely to the cavity filtration, especially you've got, like I mentioned, you might have 300,000-400,000 or more gallons of water that need to be turned over. The system you see on the heat, it looks like a heat exchanger. The system you see on the right is the actual housing for a number of these elements. And this system is probably rated at several thousand gallons per minute. This is not necessarily representative of a system that would be used in a reactor cavity because this system would more than likely be completely submerged just because of the radiation levels. But it is a high flow capacity. It's available in a variety of media, different lengths from 20 to 80 inches. The micron levels vary from 1 to 100 micron depending on the needs and the status of the contamination of the water. These housings can be mounted either vertically or horizontally. And there are a number of D&D projects ongoing right now that are using this system. The UltiPlease system is an all-plastic compressible, shreddable, and incinerable system. Although in the case of reactor cavity filtration, the likelihood of these being shredded or incinerated is very, very low. These will very likely be, because of the dose that they will accumulate, they will very likely be put in cask and shipped out as either low or medium level waste. Over the years, Paul Corporation has developed technologies for nuclear power plant decontamination, and a couple of them are shown here. On the top is 3 Mile Island. This is a metallic media called PMM media. This is a backwashable. It removes sludge from the fuel cavity. In the time it was used at TMI, it was 10 micron, but now it's been now advanced, and there is anything between 2 and 25 micron now available. At Main Yankee, the Rigimesh media, also metallic media. This is for a submersible backwash system. This was for removal of coarser material, and 18 micron was used at Main Yankee. Now available is anywhere from 15 micron up to 450 micron. And finally, nuclear processing facilities. I want to point out three facilities here and some of the unique applications that are being used. First, Sellafield. What you see there on the upper left is it's a product called AccuSep. This is a dewatering application. It develops a concentrated sludge. This is a Paul-owned technology. We have a confidentiality agreement with the site. Because of the extreme conditions and the micron levels of this particular product, there are specific government controls on this product. It actually has its origins way back in the Manhattan Project, and it is actually continued to be manufactured in Oak Ridge, Tennessee. The micron levels vary from 0.1 to 5 microns. In Hanford, Washington, you'll see what we call the PMF media. This is essentially the first HEPA filter, and this was for vent filtration for contaminated gas. It is cleanable if necessary, and the micron ratings on this range from 2.5 micron up to 40 micron. And then finally at Savannah River in South Carolina, you'll see the member locks, ceramic membranes. Being ceramic, they're very high temperature. They are used in very highly radioactive applications, and they are backwashable. These range from 50 nanometers up to 0.8 micron. This concludes today's presentation. I just want to say thank you for everyone who has registered and participated today. And again, if you have questions and you've submitted them, we will then make all attempts to answer the questions within the time allotted. And again, thank you very much, and have a great day.
Okay, everyone, I just want to thank you once again, and a few questions did come in, and I just thought I'd go over them right now. There was a question on availability, and especially on the nuclear side, because of the sensitivity of the nuclear grade components. And what I can say is the nuclear grade or the NSSS elements that go into the primary side of the plant are sold directly from Paul. That eliminates any kind of confusion and keeps the pedigree of the element when it comes directly from the factory. For the BOP side of the plant, we sell through distribution. We have two main distributors in the U.S. And the country is essentially split in half, and on the western half is the distributor is Power Flow, and on the eastern half is Fluid Flow, and they can be contacted for really any application. For a direct nuclear application, though, they will tell you that would have to come directly from Paul. And if you need contact information, you can contact me directly. My email is very simple. It's just john_Ferrara@paul.com. And be more than happy to redirect any questions or issues you have. I would like to say that we do these webinars periodically, and just to stay tuned, and you'll get the email to register for future emails, and please do so. We really encourage people to participate. The questions that come in, and the interface is very important to us, and it benefits, I think, both the suppliers and the end user. One final thing is I talked about contact info. There is a PDF version of this presentation that is available. There's a question that came in, and we can send that out to everybody, all the attendees. The information is, for the most part, it's public domain, and it doesn't have a qualifying statement on the front, but all this information is really available to the public, and we will send that out to those that are interested. Other than that, again, thanks for your time today. Hope it was beneficial, and hope to see you on a future webinar. Thanks again, and have a great day.